This video is an answer key for the half-life practice. Check and make sure you got all of them correct, and if you got one incorrect, make sure you listen to the explanation. So a few things to notice about the graph before we get started. On our x-axis, we have elapsed time in days. On our y-axis, we have the percentage remaining, and we have this really good half-life shape for exponential decay. So number one, what is the half-life for iodine-131? So the half-life is the time it takes for 1/2 of the sample to decay. So we're looking for a time, which means our answer is going to come from the x-axis. And half of our sample, that means 50% is remaining. So if we match that up, that means our half-life would be 8 days. Number two, what is the percent remaining of iodine-131 after the 9th half-life? So if we count this out, this is 0 half-lives. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the percent remaining then would be 0.20%. Number three, what percent of iodine-131 is still active after 4 half-lives? So 1, 2, 3. Here's the 4th half-life, and when it says active, we're talking about what is still remaining, what is radioactive. So our answer would be 6.25%. Number four, what percent of iodine-131 is no longer radioactive after 4 half-lives? So on this 4th half-life, 6.25% is still radioactive. So if we're looking for what is not radioactive, we're going to take 100 minus 6.25, and we get 93.75% is no longer radioactive. Number five, how many days passed if iodine-131 has undergone 5 half-lives? So we need to count out 5 half-lives. 1, 2, 3, 4, 5. So here's our 5th half-life. So how many days have passed? It's been 40 days. Number six, if 40 days have passed, that's the data point we were just looking at, how many half-lives has the sample undergone? 1, 2, 3, 4, 5. It's undergone 5 half-lives. Number seven is a little tricky. So we're looking at the fraction of the original sample if 0.1% of the sample is still radioactive. So at 0.1% here, if you would like to, you can change 0.1% into a decimal and then use your calculator for decimal to fraction. Another way to think about it is we could say, well, this is 1/2, so this is 1/4, and this is 1/8, and then 1/16, and 1/32, and 1/64, and so on until we get to this last point, which ends up being 1/1024. So that fraction is still radioactive. Number eight, how many half-lives did it take for 75% of the sample to become stable? So if we're looking at 75% stable, that means 75% has already decayed. So this is our percent remaining. After this first one, we have 50%. That is decayed, and then after this one we're going to add another 25% to it for decay, which gives us 75% has now decayed, because at this point we have 25% left. 100 minus 25 would be 75. So this would be our first and then our second half-life, so it takes 2 half-lives. Number 9 says, if the original sample of iodine-131 was 200 grams, what is the mass after the first half-life? So if 100% is 200 grams, we want to know how much is left after the first half-life. Well, the first half-life would be 50% remaining, and we know that all we did was cut that in half. So if we cut this in half, 200 divided by 2 is 100. So our answer is 100 grams. And the last question, what fraction of iodine-131 is stable, keyword stable, at 56 days past? So let's find 56 days. So at this point in time, we know there's 1, 2, 3, 4, 5, 6, 7 half-lives that have occurred. And to know what fraction is stable, Well, at this one, we have 1/2, 1/4, 1/8, 1/16, 1/32, 1/64, and then 1/128. So this is what is still radioactive. So therefore, what has decayed then would have to be 127 out of 128.